Hi there, folks. Today we're looking at proving that quadrilaterals are parallelograms, or that a particular quadrilateral is a parallelogram. And to do this, we're just going to use, first of all, the definition. All right. If we have the definition, essentially opposite sides are parallel, we can say the thing is a parallelogram. Okay. But then we can also use all those properties, and it's really the converse of each of those properties that we have. Like the first property was, a parallelogram, the opposite sides are congruent. So we could use the opposite of that. If we have the opposite sides are congruent, we can then say that the thing is a parallelogram. Okay. Likewise, some of our other properties, if the quadrilateral has both pairs of opposite angles congruent, then it's a parallelogram. And notice it's really important to have both pairs of opposite sides or both pairs of opposite angles. Okay. And then the next one, if both pairs of consecutive angles are supplementary, again, it has to be each of them. It can't just be one. Okay. And so we're kind of looking at those properties. The properties of parallelograms will give us opposite sides being congruent. Okay. So if I have both of those opposite sides congruent, I can go backwards and say it's a parallelogram. Okay. The properties give us both pairs of opposite angles congruent. So if I have those two pairs of opposite angles congruent, I can go backward and say it's a parallelogram. Okay. The properties give us that the consecutive angles are supplementary. But if I have each of those pairs of supplementary, of those consecutive angles supplementary, I can go backward and say it's a parallelogram. Okay. And then the other property we have is that the diagonals of a parallelogram bisect each other. So if I have the opposite, if I have diagonals in a quadrilateral that bisect each other, I can go backwards and say the thing is a parallelogram. So it's all those same properties. We're just using them in reverse, okay? And so kind of think about it from that perspective. If I looked at something like this, it says, find the value of x and y that make A, B, C, D a parallelogram, okay? And so I don't know if this is a parallelogram, but what values would make it a parallelogram? Well, if I were looking at this thing, if opposite sides are congruent, it would make the thing a parallelogram. So if, y were to equal the x plus 2, and if the 2x plus 1 were to equal the 3x minus 5, then that would make this thing a parallelogram because it would make the opposite sides congruent. Okay, so it's the same questions we've been answering, but just from a different perspective. Okay, and once again, this guy, as I kind of went through this, you could look at this almost like a system of equations, but look at that second equation, it's all x values. And so here, if I subtracted the 2x from each side and then added that 5, gives me a 6. Now I have to plug it back in over here. Okay, that's it. Okay, so we're just looking at it from a different perspective. Before we were saying, hey, this is a parallelogram, so these are congruent. Now we're saying, if these are congruent, then it would make it a parallelogram. All right, so here we're going to have one special theorem for proving that quadrilaterals are parallelograms that isn't directly one of our properties in reverse. So it's not a converse of one of our properties. So here I have that I have one pair of opposite sides parallel. So I have AB is parallel to DC or CD. And I have that same pair of sides is congruent, okay? And this is a little bit different. We're used to having two pairs of opposite sides congruent. Now I only have one pair, but I have, in addition to that pair of opposite sides being congruent, that those opposite sides are also parallel, okay? And so with just that information, I want to prove that this thing is a parallelogram. So this is kind of a special one that's not quite as obvious as the others. The others are really obvious because it's just the reverse of our properties. This one's kind of special. And so as I kind of start to think about this proof and start to map it out, really, I don't have a lot of information as I look at this thing from the perspective of just having parallel sides here and congruent sides. So I'm going to have to draw an extra piece as I have to sometimes. So I'm going to draw a diagonal. Wow, I completely missed. Let me try again. I can do better. I believe in me. Let's go red. That was the problem. I tried drawing in blue. Silly Mr. Jansen. But anyway, if I look at something like this guy, now think about this from the perspective of looking at the two triangles, and we should be able to come up with this thing being a parallelogram, okay? And so as I look at something like this guy, the first thing I would probably do is I'd probably label some of these angles like this one and this one. Okay, I'm going to call that angle 1 and angle 2. And so if I kind of ignore those side pieces, AD and BC, if I just look at DB as a transversal connecting those two parallel lines, 1 and 2 are alternate interior angles. And so if those are congruent and the sides I already have are congruent, and I know that DB is congruent to itself, I already have the 3 pieces I need for the triangle. So let's put this into a proof. So I've got my statements and my reasons here. So I'm going to start with what I know, what is given. And again, that's given, so I'm just going to say that it's given, all right? I was given those pieces of information. And then from here, and, we could include that, hey, we drew DB, all right? I think it's okay that we kind of just showed it off to the side. If you want to put it in here as step 2, I constructed diagonal DB, that would be okay. I'm going to go right to just saying, okay. Well, if I draw that thing, I know that angle 1 is congruent to angle 2. And that's because of alternate interior angles of parallel lines. Okay, so alternate interior angles of parallel lines are congruent. And then from here, I could say that something like DB is congruent to itself. And that's my reflexive property. And so now what I have is I have the 2 triangles are congruent. So from here, I could say that triangle ABD is congruent to triangle, let's see, C, I got to make sure I label it in the same fashion, DB, okay? And those 2 triangles are congruent because of side angle side, okay? As I look at this thing, and maybe I can label it up here, those 2 dashes. So right here I had, side AB, then angle 1, then then side BD. In the other triangle, I had kind of the same thing, CD, angle 2, and then DB, okay? So side angle side. And now if I know those 2 triangles congruent, I know that all their pieces are congruent. And so there's a bunch of routes that I could go here. But the shortest one, all right, is just to go right to those opposite sides, AD and BC, and use that property, okay? So I'm going to say that AD is congruent to BC, and that's CPCTC. And now if I have those sides congruent, now I have both pairs of opposite sides congruent, which allows me to say that this thing is a quadrilateral. Or sorry, is a parallelogram. So now I can prove that ABCD is a parallelogram. And that's because opposite sides congruent. So it's a parallelogram. Okay, that's the rule that we have, okay? And that goes back to one of our other values. So think about what that's done for us. By proving this, now I have one more way that I can show that these are parallelograms. And this way doesn't require both pairs of opposite sides. It only requires one pair. But as long as I know that that one pair are both congruent and parallel, I can say that it's a parallelogram, okay? And really, when you think about it, we need 4 things in each of these, okay? We need 2 pairs of stuff, all right? Whether it's both pairs of opposite sides congruent or both pairs of opposite angles congruent, or just one pair, but I need 2 different things. I need that pair to be congruent, that's 2 things, and that same pair to be parallel, okay? So if a quadrilateral has one pair of opposite sides that are both parallel and congruent, then we can say that this thing is a parallelogram, okay? So we have all of those properties that we can use in reverse, all right, to show that it's a parallelogram. And then we have this special one where I just look at one pair of opposite sides, and if they're both congruent and parallel, then I can say that this thing is a parallelogram, okay? And now if I look at these, let's determine if each of these is a parallelogram. And I might not be able to determine if it's a parallelogram. And so as I look at this, let's look at the information I have. So this one, I'm given these 2 angles. And given that these 2 angles are supplementary, the thing is, though, I can't use that rule that says if both pairs, if two pairs of consecutive angles are supplementary, because I would need this pair to be supplementary as well. Okay, so because I only have one of these sets, the only thing that tells me is that the opposite sides is that this guy is parallel to this guy. Okay, and I can say that those are parallel because they're same side interior angles. But now I have one pair of sides, BC and AD, that are both parallel and congruent because of the sevens. So I can still say that these are that this is a parallelogram, but maybe not for the reason that you originally thought. Okay, so I can say that this is a parallelogram because of that special theorem that we've just proven. Okay, so this is parallelogram ABCD, and it's because of, so make sure you understand the justification. It's because of I have one pair of opposite sides that are parallel and congruent. Okay. If I look at the next one, I notice that I have these sides congruent, and then separately I have these sides congruent, but those are not opposite sides. These are not opposites. These are not opposites. Okay, so there's not really much I can do here. I don't know anything about the angles, and I don't have the opposite sides congruent, so I cannot prove that this is a parallelogram. Okay, so I'm just going to write no. Okay, not enough information, can't be done. All right, not enough information here. If all of those sides were congruent, then I could say it's a parallelogram. If I look at this guy, same kind of thing. As I look at this, when I look at the angles that I have here, so looking at these two angles, okay, being congruent, if those two angles are congruent, those are alternate interior angles for these two sides, which means by those being congruent, I know that these sides are parallel, okay? And then if I look at the other pair right here, these guys being congruent, well, those are alternate interior angles of these two sides. So by saying that those are congruent, I could say that these two sides are parallel. Okay. And notice I don't have opposite angles of the parallelogram congruent. What I have are angles that give me the sides being parallel. And so as I look at this one, I can say that this is a parallelogram. But my justification is the definition of parallelograms because I have opposite sides parallel. Okay? If I look at this guy, I have one pair of opposite sides that are congruent and the separate pair that are parallel. And so students will tend to jump on this and say, oh, it's a parallelogram because I have a pair that's opposite, a pair that's congruent and parallel. But it's got to be the same pair. That special one has to be the same pair of opposite sides, both parallel and congruent. And these are different sides. Okay. And so maybe there's still a justification here. So maybe we start drawing some of this stuff and we start talking about like these angles being congruent. But when it's all said and done, we don't have enough information here. Okay. And so as we look at this thing, I've got those angles. I even have something like this side here. So maybe I could go through a proof of justification saying, hey, I've got two congruent triangles here by side angle side. Okay. But really, I don't have any of these properties. So I could maybe prove this to be a parallelogram through a proof of some sort, but I don't have it right away. Okay. And so this one, I'm going to say not enough information for now. So I'm just going to say no. Because I can't justify it with one of the things that I have, okay? Maybe I could go through a proof to come up with it, but I can't justify it using the things that we've discussed so far, okay? If I look at this guy, we're going to construct a proof this time, and I've got BC is parallel to AD. Let me label that on my picture. And I've got triangle ABE is congruent to triangle DEF, so it's this little triangle here and this little triangle here are congruent. And now from here, I want to prove that this whole thing, that the bigger picture, the ABCD, is a parallelogram. And so start thinking about what we know. We already have a pair of parallel sides, so maybe I'm thinking, could I show that same pair of sides, BC and AD, are congruent? Because that would give it to me, okay? Or maybe I could go the route of the definition and try to prove that AB is parallel to DC, okay? Or maybe I could somehow prove that BC is congruent to AD, or maybe that AB is congruent to CD, that kind of thing. So we're kind of looking for our options here. And really, the two that make the most sense are trying to prove that BC is congruent to AD, or trying to show that AB is parallel to DC. Okay, so go in the route of that special theorem or go in the route of the definition. And so let's think about what we know as I start to think about knowing that, the two triangles are congruent. Well, right away, I would know that like these guys are congruent because of CPCTC, or these guys, or these guys. And maybe you're looking at that thinking, well, I don't know if that really helps me or not. But maybe you would look at something like this and say, hey, this angle, angle 1, and angle 2 would be congruent because of CPCTC. And so as you look at that, hopefully you recognize that those are alternate interior angles for lines A, B, and C, D, which would make them parallel. And so let me erase all the stuff that's probably not going to help me. If I think about just that information, that would give me opposite sides parallel, which would give me this thing through the definition. And so let's kind of construct the proof off of that. And so again, I'm just kind of thinking about what I know to try to figure out, all right, do I have a path to this thing? And then constructing the proof, we're just going to write out that path, okay? Let's see, BC is parallel to AD, and triangle AB is congruent to triangle CDF. And all of that is given, so I'm just going to say given here. Okay? And then from here, let's talk about what we discussed. We said, hey, you know what? Let's talk about the fact that angle 1 is congruent to angle 2. And yeah, I labeled them that way. But angle 1 is congruent to angle 2. And that's because of CPCTC. And now from here, if those two angles are congruent, again, if you think of AC as the transversal, well, 1 and 2 are alternate interior angles for lines A, B, and C, D. So I can immediately say that AB is parallel to CD. And I can say that because the alternate interior angles were congruent, that makes the lines parallel. You can just write it as an if-then statement. If alternate interior angles are congruent, then we have parallel lines. Okay? And now from here, so here's what I now have. I have these guys are parallel. Well, I have both pairs of opposite sides parallel. Well, that's the definition of a parallelogram. So now I can immediately go to saying that, hey, I have parallelogram ABCD, and that's because of the definition of a parallelogram. Okay, so I'm using what I know. I'm trying to get those properties. I'm trying to find one of those properties that's true because that will show me that the thing is a parallelogram. That's my route for proving that I have parallelograms, okay? Is I'm still using those properties, okay? But I'm trying to show that I have that property so I can say that it's a parallelogram, okay? And then we have that one additional property. If I have one pair of opposite sides that are both parallel and congruent, well, that makes the thing a parallelogram, okay?